So thank you, Andrew, for that kind of introduction. And it's so refreshing. I've spent the last 3 years on COVID. Every time I give talks, it's about COVID and the COVID vaccine we're developing. That it's so wonderful to be here talking about something very different. So I'm going to be talking really here at the interface of biology and theology, and looking at the question, who is Adam and how did he die? How did he fall and die? So according to 2014 ECF, so ECF is Biologos, which is a evangelical group, and I'm very close with them. They're really cool. And if you ask, this is in the United States, if Adam and Eve are real people, 56% of respondents would affirm that statement, that Adam and Eve are real. And yet there are many contemporary theologians, both Protestant and Catholic, and this is just one of them. This is Jesuit Father Jack Mahoney, who is now retired at Boston College. He said, "I argue that with the acceptance of the evolutionary origin of humanity, there is no longer a need or a place in Christian beliefs for the traditional doctrines of original sin, the fall, and human concupiscence resulting from that sin." And that's actually very typical of many authors if you want to read about this today. The primary reasons, and I will not have an opportunity to really go through all of these reasons, but these are the three major ones that are given. So one is there's an incompatibility with a critically informed reading of Genesis, and clearly Genesis says this, science says that, they're not the same. Incompatibility with an evolutionary account of human origins, and it's really interesting. So there's a moral side to this. There are a lot of theologians who would argue that an account of original sin actually removes personal accountability with regards to the evil that we commit on a day-to-day basis. Now, the Catholic Church, if you look at her official position, if you look at the Catechism, it will say this in paragraph 390. The account of the fall in Genesis 3 uses figurative language, so there is this acknowledgement of the critical engagement with sacred scripture, but it affirms a primeval event, a deed that took place at the beginning of the history of man. And that revelation gives us the certainty of faith that the whole of human history is marked by the original fault freely committed by our parents. So there's this tension between a historical reading that something happened in the past, we're not quite sure, but we need that something to explain what's going on in the present, and then with a very critically engaged account of how to read sacred scripture. And so what I'm going to be doing today is to ask this question. Can we provide a coherent narrative that defends historical Adam after Darwin? Now, if you looked at the church's theological reflections in the last several decades, what you will see is that the church is beginning to be open to accounts of polygenism. So polygenism means multiple couples, monogenism is one couple, and monogenism has been the church's position for millennia. But in recent years, especially if you look at the musings of the International Theological Commission, what you will see is that the church is exploring the possibility of opening up an intellectual space where we can think about polygenism and the relationship between polygenism and the theology surrounding original sin. But I'm actually preceding that. I'm actually asking, before we get rid of Adam and Eve, are we sure we have to? And I'm trying to defend an account where we have at least where we can coherently talk about an Adam and an Eve in a world that is evolving. So the outline of my presentation, which will last about 45 minutes, we have I'm going to talk about original sin, then original DNA, and then original history. And so you've got the theology, the biology, and a synthesis of faith and reason in the third part. So we're going to talk about original sin. And when I teach this in my moral theology class, because we have to do that, is I have to begin with the doctrine of original sin. And I'm just going to put it this way. It's a theological theory to explain the human brokenness that cannot be attributed to personal fault. So a lot of people will think that original sin is about something historical. It's not. It's actually an attempt to explain what happens now. Why is it that, as St. Paul would say, you do the things that you don't want to do, and you don't do the things that you want to do? And this is a theological theory about human brokenness. And so why do we need it? So it's interesting because a lot of people will say, well, as Father Mahoney would say, we'll just get rid of it. And we have to be clear about what it's doing. What is it doing in the network of concepts, in the network of beliefs that surround Christian doctrine? This is it, the doctrine of original sin. Basically, there's a transition from the state of what is called original justice to the state of corrupted nature. And this is the doctrine of original sin. Now, let's say you get rid of it. Okay, so let's say we get rid of the doctrine of original sin. I would say the primary challenge to that is the following, that if you get rid of the doctrine of original sin, if you remove this account of original justice, and you simply say that we were created with corrupted nature, then what you're going to say is that sin flows from human nature as God had intentionally created. And that's a huge problem. It's not a huge problem for us, it's a huge problem for God. Because now God deliberately creates us broken and an imperfect state that predisposes us to failure. It's about God. See, this is the thing I tell my students all the time. The doctrine of original sin, as is all theology, as St. Thomas would have it, is all about God. And original sin helps us to understand how we can have a good, almighty God and yet feel broken in the way that we are. And it reconciles us to this statement from the first opening lines of Genesis. God looked at everything he had made and found it very good. And so there's an all good God and there's a broken us, and you have to explain how those two are compatible theologically. So now for Catholics, unfortunate for the Jesuits, you can't get rid of it because it's already part of Catholic faith. It was defined as such, de fide, in the Council of Trent in the decree concerning original sin. So this is one of those data points that you must incorporate into your theological musings. As I explained to my students, I'm first, professionally I do most of my work in biology, and we have data. And we have certain data, and then there's data that's provisional. This is certain data. So you have to incorporate this into your model building for what you think is going on. So this is the Thomistic account. Again, it's just in summary form. So in original justice, you have sanctifying grace. And Father Andrew beautifully explained about sanctifying grace yesterday. Then you have preternatural gifts, integrity, infused knowledge, and immortality. We were not broken. Calculus was really easy, and we didn't die. That's really what that means. Now, fallen nature, loss of grace, and we've talked about, Father Andrew talked about that yesterday. And you have the loss of the preternatural gifts. So what you have is you experience that disorder within. And that disorder is experienced, in a sense, prior to intention. You have to acquire knowledge. We have universities because, in a sense, of original sin. It's a striking thought. And then we die. Now, in another paper, it was published in Nova et Vetera, I talked about preter-adaptive gifts. So one of the things we have to reconcile is that if evolution is true, there are natural inclinations and dispositions that we inherit simply because they were adaptive during evolution. So the primary one that I talk about is if you look at basically animals out there, what you discover is animals are predisposed to extramarital copulation. This is mate choice, where males are inclined to mate with females that they're not mated to for life. We call that adultery. And there's a predisposition in us, based on evolutionary theory, for this. And so the question now is, in addition to the preternatural gifts that Aquinas posits, I had to go ahead and talk about preter-adaptive gifts. So these are additional gifts that the Lord gave to our first parents in order to counter the defects associated with the evolutionary process that gave rise to our bodies. So there's preternatural gifts, then preter-adaptive gifts. They're not necessarily exclusive in terms of how they influence the human person. So that's the theology bit. So now I need to go into biology a little bit. And since I'm not sure about your biological background, I'm going to start from the beginning. So the question here is, when did you appear in evolution? And so this is a beautiful image that looks at the different alleged, presumed ancestors for Homo sapiens. That's us right here, Homo sapiens. One of the things is we're not really sure of the directness of this. And this is, the evolutionary tree is not a straight line, it's a bush. And you're not really quite sure exactly all of the branches and how they lead to the current us. So the question now is, most of evolutionary history is done genetically. So in the past we had all these archaeological fossils, now we have genetic fossils as such, and we look at the human genome in order to see what secrets it keeps or it can reveal about our historical past. So the human genomic science, this is called paleogenomics. This is the most cutting edge science we have today. And Svante Pääbo received the Nobel Prize for his pioneering work in this area last year. So the genome is all of the genetic information in an organism. So what most people, well, first of all, you see this is a cell, and the nucleus, which is kind of like headquarters for the cell, has a nuclear genome, and you have the 46 chromosomes, 23 from mom, 23 from dad. And what most people don't realize is we have another mitochondrial genome. So the mitochondria is the energy, the power plant of the human cell. And we have the mitochondrial genome, which is only inherited from the female. So this is the origin of the whole mitochondrial Eve account, where all of us here today are descended from a single woman. What we can also do is we can look at the Y chromosomes of males. We can look at, and we can see that all of the males on the world are descended from one male, but they didn't live at the same time. So now this is where, a lot of people think, oh, this is Adam and Eve. I can't get into that right now, but to say that we're all descended from a single female does not mean she was the only female amongst her peers. The same thing will be said about the male. Just because we're descended from a single male doesn't necessarily mean that person was the single male. And the best way to explain that, you can look at a population of individuals, families living on an island. Let's say you have 10 family names. We're using family names simply because those are inherited over generations. You can see that over time, if say 500 years ago, there were 10 families on an island. Over the course of time, you could have a situation where this family disappears because there are no boys that are created. They don't have any sons, or they don't have any children. And so this family name disappears. You might end up with a situation where the entire family is Shaw. So every single individual there is now named Shaw after 500 years. That's because the Shaw family lineage is the only lineage that survived after 500 years. This does not mean that 500 years prior, the Shaw family was the only family that lived. It just means that over time there's competition between different hereditary lines, most of which are going to run out. So if you look at one of these chromosomes, you can spread them out, and voila, you see the double helix. Now, again, a real interesting fact is if I spread out all of your DNA end to end, it will end up being about 2 meters. Now, the largest cell in the human body is the human egg, which is the size of a period at the end of a Times New Roman 12 font sentence. And one of the most amazing biological questions we do not know right now is how we organize that 2 meter long spaghetti string in a way that can fit into a very, very small volume without losing sight of the location of the spaghetti. Think about a bowl of spaghetti. If you wanted to find a very specific point on one spaghetti string, you'd be like going through all of that spaghetti. And yet here the cell is organized in such a beautiful way. We don't understand how it's organized. We have some hints that it's able to go through this library of 46 volumes, 46 chromosomes, and quickly identify which gene to turn on and off at a particular moment in time. And that's the genetic code. This is the epigenetic code, which is still being worked out. And it's one of the questions that we're going to face this century. So the 20th century was the century of physics. The century before that was the century of chemistry. And you are living in the century of biology. This is our time. And you can see that most of the discoveries. And you can see this actually because I have physicist friends who are now doing biophysics, because most of the money at the in the United States is in biology at the NIH rather than at the NSF. And so this technology, you see all the technological advancement, it's all primarily biological, not physical or chemical. Now, if you take one of these DNA strands, you can actually indicate it. DNA is made up of 4 molecules, each has a letter A, T, C, G. And in fact, this is the gene. So this is the gene that my students and I have been studying for the last 10 years. Prior to the pandemic, we worked out this gene. This gene is upregulated, it's turned on in certain tumors. And so my students at Providence College, we worked out this gene. This is a yeast version of the gene, which is easy because then you can kill yeast cells without any ethical issues, to see whether or not the gene is involved in cell suicide, and it is. And trying to figure out how this works is what I spent 10 years of my time in Providence College doing. And we were looking for new chemotherapeutic agents that downregulated this gene for possible treatments in tumors. Right now, the COVID changed everything. So now we've shifted over to COVID work and vaccine development. But hopefully you can see that DNA can be indicated as text. And so I want you to see DNA as text. That's why my analogy of genomes is 46 chromosomes, is 46 volumes. And so you can compare and contrast genomes in the way that, say, scripture scholars compare and contrast manuscripts. See, now you can see that. See, our brothers, the Dominicans who work in the Leonine Commission, or looking at the original texts of St. Thomas Aquinas' work, will take all the manuscripts that they can find and then determine the historical relationships among them by looking at errors in copying and looking to see what was the original manuscript. And we can do the same thing now with genomes. And so think about it this way. If you have 10 final exams with similar answers, what could you deduce about this? You would say, what does this tell us among the relationship among them? It's a common origin. We call that cheating. So cheating is common origin. There was a point where one exam became 2, right? And this is one exam, and then it became 2 because it was copied. And so we can do the same thing now with genomes. We can compare them and look for common origin. And so this is an example. So this is the gene for casein beta, which is the most common protein in cow's milk. And you can see that these colors indicate identities. So you have this letter G here. It's common across all of the different genomes. And you can do the same thing across the board. And what actually happens is you can come up with a family tree of all these genomes. One striking thing is that the closest relative to a whale is a hippo. This is one of the reasons why biologists will say that whales, the ancestors of whales were tetrapods, 4-legged animals that lived on land, right? So because genetically they're mostly close, their genes are most closely related to the hippo. So you think about the hippo as, a pre-whale. Now, so there are a couple of genetic principles that we've worked out by doing all of these studies. So more closely related genomes have a more recent common ancestor. You have 2 exams, and those exams only have one answer in common. It's likely that person copied very early on. If all the questions are exactly the same, then the copier had to wait until the original student had written all the answers. So it's closer to the present before the copying happened. So that's genetic principle number 1. Genetic principle 2 is then the differences between the genomes can be used to estimate the historical time since the common origin. And so what we can do now is in terms of our ancestry, we can approximately, the common origin between chimpanzees and humans is 6 million years ago. This does not mean we evolved from chimpanzees. It means that we and chimpanzees have a common ancestor, and that common ancestor is neither chimpanzee nor human. And then 10 million years ago, there's gorilla and human. We can then take this human lineage and we can expand it even further. So there's us, modern humans. Then there's Neanderthal and Denisovian. And again, 500,000 and 1 million years ago. Both of these extinct. Some my students say, no, they live in New York. So the Neanderthal right there, that's extinct. And so we can compare all of these genomes to figure out what's similar and what's different. We can take the modern genome even further, and you can see that this is what happens. So I'm here, I'm an Asian, modern humans, there's European, and we know that about 100,000 years ago, all of the human populations had a common origin about 100,000 years ago. And so this is the most current model. It's the out of Africa model. The idea is that all of us have origins somewhere in Africa, and the entire world is descended from a population in Africa about 100,000 years ago. And you can talk about 15,000 years ago, they basically start to migrate down to South Africa, and then Australia 50,000 years ago. And it's interesting, when the humans get to Australia, our ancestors, all the megafauna, so they're giant birds and giant mammals live there, they've never encountered humans, so they're not scared of humans, so they're easy food. Remember, so they come up to the humans and go, who are you? And then humans would kill them and chow down on them. So that's why you have significant extinction of the megafauna around 50,000 years ago in Oceania. So the first scientific consensus is that we have a common origin 200,000 to 100,000 years ago in Africa, and they dispersed from Africa about 60,000 years ago. So how many mating pairs? This is really, really important because this is what we're talking about with regards to Adam and Eve. So I'm just gonna, this is Daddy Beagle and Mommy Beagle, and you can see here are the baby beagles. And does this make sense? Yes, it does. What happens if I do this? You go, this does not make sense, right? So you're gonna say that this, if we have two baby beagles and a Dalmatian, you must have this historically. And so biologists do this. We can look at the current situation, we can look at the genetics of today, just like we look at all these, and then we can model and work out how many must have been however number of years ago in order to explain what you see today. And basically it's 1,000 to 2,000 mating pairs. It cannot be smaller than that. If it's smaller than that, it does not explain the diversity you see today. We never ever go down to one. The smallest number is 1,000 to 2,000. And then we also know that there's been mating between different branches. So I'm Han. So Han is the population group that includes all Asians that are descended from people who had origins in China. I had my DNA scanned. I have 4% Neanderthal genes. And most of you here are going to have some range of Neanderthal genes. And it's interesting because some of the Neanderthal genes predisposed to COVID-19 and some of them protected against COVID-19. So one of the reasons why it was so devastating in India is there's a version of a gene in populations in India that predisposed to severe COVID, which is why, if you remember the Delta surge, there were massive numbers of death, especially in the eastern portions of the Indian subcontinent. And it's been linked to versions, alleles of genes that are associated with the Neanderthals. So we know that Neanderthals and Denisovians mated with our human ancestors. We carry that gene. And so if you are Melanesian, if you're from New Zealand, and we're not talking about the Caucasians who colonized, we're talking about the original native peoples, you actually have genes from Neanderthals and Denisovians. Now, if you look at the recent evolution of our genus, so this is us, anatomically modern humans. You will notice there's if you look at our history, recent history, so this is 200,000 years ago, what you discover is that there is a critical step. If you go back 250,000 years ago and look at the fossils of the humans who lived then, they looked like us, but they didn't behave like us. So you have behaviorally modern humans. This is culture. So you have the appearance of jewelry, the appearance of musical instruments, the appearance of painting. So they've looked like us for 200,000 years, but only recently, in the last 100,000 years, did they behave like us. And so this is a very interesting question, Mark, about what happens there that leads to the transition between anatomically modern and behaviorally modern human Homo sapiens. So I'm going to spend some time looking at that. And this is a reconstruction of a behavioral human from 28,000 years ago. And they can do this from a skull now. And so this is a reconstruction. But the key question really, from our perspective, is the following. When would you have recognized a hominin ancestor as someone like you, right? So we're looking from the present, looking to the past, looking at all of our possible ancestors and saying, when would you recognize one of these as us? So the question we have to begin with is, what are you? And this is the philosophical point. You are a rational creature capable of abstract thought. This is an Aristotelian Thomistic account. I'd like to explore this a little bit. So abstraction, again, allows us to conceive of a single concrete individual using numerous universal concepts. This is what you and I can do. I was at a talk in Germany, and a lot of people were saying, well, animals are like us, we're like animals, we're both intelligent. I said, well, intelligence has to be defined and distinctions have to be made. We're talking here about this very unique skill of abstraction where you and I can take a single concrete individual and we can understand that individual in different ways. So if I go, what is this? You can say the following. It is a thing, a gadget, a cell phone, an iPhone. Each of this is a universal. They're all true, and they all refer to the one thing. Now, we know that animals don't have the capacity to do this. They can recognize that object. That's a bone, and they'll go running for it. But they can't just start talking about this is a bone, this is also food. So they don't have that capacity. So the question now is, if this is what defines us, as Aristotle and Aquinas would have it, when did abstraction first appear in evolutionary history? That's really the question we have at hand. And so this is the proposal I'm going to make. Abstraction and the capacity for hierarchical language appeared in evolutionary history simultaneously, and I'm going to have to make my case for that over the next couple of slides. So one, abstraction is necessary for hierarchical language. I am not talking about generic language, because a lot of my friends will say, my students will say, dolphins have language. They do, but their language is linear language, and we know this because we can record it, and then we can scramble it, and they get confused. But our language is hierarchical, and I'm going to show you what that means, okay? So what does this sentence mean? Matt is too angry to eat. Now notice it's a single sentence in English, but it has two meanings. You see? So this is the interesting thing. It's hierarchical because we know it's only because it's hierarchical that it can have two meanings. If it was linear, it would only have one meaning because the meaning would be tied to the linear order of words or sounds. But in this case, there are two meanings. One is, Matt is too angry that he cannot eat. But the second one is this, Matt is too angry that I cannot eat him. Can you see that? That's abstraction. It's also what you notice, abstraction is the property that allows you to get jokes. You see, just now your reaction is what would happen if I said a joke, you go, oh yeah. So, and Aristotle said hilarity, the ability to laugh, is a characteristic of humans. Matt is too angry that I cannot eat him. Now you notice, abstraction allows us to understand the multiple meanings of a single sentence. And it's inherent to human language that we have that in all the languages. It is necessary for hierarchical language. If you remove abstraction, you can't have hierarchical language. But the same thing is true. Hierarchical language is necessary for abstraction. This is the reverse. I've argued it's the reverse. Because if I say this, what is this? Now I don't know. Does anyone know what this is? It's not a lychee. It's a rambutan. Now I had to do something like this because I go, ooh. Now it's interesting because if your mind, the way you will do this, so let's say you saw something like that for the first time. What you would do as a human being is you'd look at that, you'd go, oh, it's a fruit. I think it's fruit. And you'd start talking to the person next to you and you go, what is that? It's a fruit. Is that a lychee? And you compare, and now your process, Aquinas will say, it will be a moving through forward and back. You will be looking at this, and you will be going through all the possible universals that you could imagine trying to focus down to the universal that the name of that thing, the specific difference. These are all different universals. It's a thing, it's an object, it's a fruit, it's a rambutan, which is delicious, by the way. Now that I'm assigned to the Philippines, I can get it all the time. You can't get this in the States. You could, it's frozen, it's disgusting. So you get a rambutan, and it's the ability to undergo abstraction it's hierarchical language is what allows you to work through this. And it's interesting. So most people assume that language evolved primarily for communication. Who do you spend most of your time talking to? Yourself. So it's actually so we now understand language has evolved primarily for cognitive work, not for communicative work. And it's only secondary that if you find someone else who has the capacity for language, and we know this because in Nicaragua, some years ago, they tried to set up, they wanted to get the deaf kids to learn American Sign Language. So what happened is they sent some Nicaraguans up to the US to learn American Sign Language. They brought them back down. Then they brought these kids together for the first time who had never met anyone else who was deaf. And so they started teaching these kids American Sign Language in class. Now, the teachers were not native speakers of American Sign Language. They had gone up to the United States to learn it. What was so striking is they discovered in the playground the kids had developed Nicaraguan Sign Language. When they encountered each other, they had created and invented a new language in order for them to communicate. And so you see that once you put two individuals with capacity for language, they will start generating a language on their own. So hierarchical language allows us to distinguish universals during the process of abstraction. It allows us to sort accidental qualities and distinguish them. So if you have a lychee and a rambutan, you will go, what makes a lychee a lychee? What makes a rambutan a rambutan? You actually have to talk either to someone or to yourself to figure out what distinguishes them in order to specify them as two separate kinds of things. So we are rational animals because we are also speaking primates. So just like Aristotle would have a genus and a specifying difference, a rational animal, I would say we are primates, but what specifies us is we are speaking primates. And once you get here, you see, you can now put it all together in original history. This is the account of Adam and how he fell. So if you go to Noam Chomsky, he will say, Noam Chomsky, professor emeritus of linguistics at MIT, it evolved primarily as a cognitive tool, not a communicative tool. You're not using it primarily to talk to people, it's a cognitive, and it's the ability to combine infinite numbers of hierarchical conceptual structures that convey symbolic meaning. This is basically language. But what's really cool about this is he will say it appeared in one person. Somewhere in that group, some small mutation took place, leading to the great leap forward. It had to have happened in a single person. So the current account actually is that you had this population of 10,000 original hominins in Africa somewhere, 1,000, 2,000 mating couples. In one of them, there's a mutation that allows the brain to be rewired so that that individual is now capable of language, hierarchical speaking. And so what happens now, and if you look at Ian Tattersall, who is the curator of the American Museum of Natural History, he will talk about the invention of language as the singular time which can explain the movement from anatomically modern to behaviorally modern. It is the creation of language that allows us to have art, that allows us to have music, it allows us to have all the things we associate with culture. And so it's the only plausible one, and it appeared in a single one. So I'm proposing the first individual of our kind was the first hominin who evolved this linguistic capacity. It's a single person. The brain was changed in a way that allowed this person to speak. So when would you have recognized a hominin ancestor, someone like you, when you were able to recognize and to speak with him? Now it's interesting, we all have the common linguistic ability to learn any of the 7,000 extant human languages. So if I took you, And it's interesting, I learned yesterday that young Irish children are learning Gaelic. And the idea here is that you take any human, you put the human anywhere with any human community, that human will be able to eventually learn that language. And so the idea is that linguistic capacity is universal enough to encompass all these languages. And so we would be able to speak with this person in time. And we would now say this first speaking hominid was Adam. And it's striking that if you go to the Genesis, Adam is the one who goes and names all of the animals. Now, because we all speak, we must all be descended from him. Remember, if speaking is a biological change and you have that ability to speak, you must have inherited that biological change from that individual. So we know that every single human is born today, and I've talked to pediatric individuals who work on children's language disorders, and they say no one is born without the ability to speak. It's sometimes they have grammar processing that's a problem, but not the ability to get language. And so we're all descended from him. And so one possible model is that hominids evolved into archaic humans that are anatomically modern, about 200,000 to 1,000 years ago. And at a single moment, God infuses an individual hominid with a spiritual soul. At the moment, he has evolved the neurological capacity for hierarchical language, and his name was Adam. This is the first individual. And Adam falls through sin of disobedience. We don't know what it is. It's interesting, if you look at Dante, how long was Adam in a state of original justice? I think like 7 hours. So we imagine they were like dancing in the garden for a long time. I think most of the ancient theologians thought of it like this thing kind of happened really fast, because for the angels it happened in moments. So the idea is that human beings were, within 7 hours he had fallen. So he rejects God, who's the giver of all things, with grace, with the preternatural gifts and the preadaptive gifts, and his descendants would migrate out of Africa. Since all of us can speak, we're all descended from him. And we both inherit his linguistic capacity as well as the fallen, corrupted nature, lacking grace, lacking the preternatural gifts, and lacking the preadaptive gifts. So that's it. That's like my kind of model. And so I'd like to thank, so this is ThomisticeEvolution.org. This is a project that the friars of my province, the province of Joseph, have been working on for some time now. We've just incorporated lay people, lay scholars. It's been great. And the goal here is to provide intellectual resources to help Catholics who are struggling with evolution using the insights of Thomas Aquinas. So we've just published, we have two sisters, Dominican sisters from the Congregation of Mary Mother of the Eucharist. They both have PhDs, one in biology, one in engineering, but they came out with a series of videos to explain faith and reason for high school kids and homeschool kids using Thomas Aquinas. We have a manuscript of scholarly papers addressing a lot of the questions that skeptics and critics raise in this issue. It's going to be submitted to the CUA Press at the end of this month, thank God willing. And we're renovating our website. We're putting YouTube videos and things on that. Again, there was a temporary break because I got so involved in COVID that everything else came to a stop. But by the grace of God, COVID is now moving into history, and so I can get back to this. So thank you very much for your kind attention.